Okay, so this is up here is the two formulas we got last time, or two of the major ones, I guess. And then we got two more for today. And so if we're looking at this thing, if we're just going to do compounding once per year, then actually we could write another formula for this. And if we do 1, if we let n equal 1, this is what we'll basically get for another formula. And so sometimes when I'm teaching this, I will actually start out with this formula. And so say we deposited, I think you were saying, what, 1,200 for 5 years, something like that?
Yeah, I don't know. I don't know that it matters on the deposit amount. I think it's like $1,000 per year.
Depositing in once and it's being compounded once per year?
Yes, that's what it looked like.
Okay, so he's doing 1,000, is that what you're saying?
Yes.
And the APR was what, like 5% or something?
Yes.
Something like that. Okay, so like pretty much everything else, I think we're just filling in. We're doing a principal of 1,000. We're doing 1 plus the APR, so we're doing 1 plus the 0.05. And we're doing this for how many years, did it say?
Let's do 20.
20 years. And so we're going to raise this to the 20th. And so we're looking at this. There's a sort of thing that we're doing here. We're depositing $1,000. And each time, you could look at this as being like 105%. So we're multiplying by 105% 20 times because we're doing this, compounding it a total of 20 times throughout the years. And so another way you can think about this is it's an increase of 105% 20 times, basically, is what we're doing to compound this thing. And so we're doing once a year. It should look something like that. And so the formula should actually like be a little bit simpler. Sometimes, like I said, I start out teaching this formula and then I'll go to the other one.
So this is if you're compounding only once a year, right?
Yeah, if you're compounding once per year, you can use this formula. It is just this formula with 1 plugged into the n. If we divide by 1, that does nothing to my APR. I can just write APR there. If I multiply my y by 1, I'm just doing y. I'm just multiplying by 1. It's the identity. It's not going to do anything to it. And so this is just this formula plugging in n equals 1. And I think the book even has this formula separate, and they introduce it first. Did I even? All right, I've started.
So what's your answer that you get on that?
So 1.05 to the 20th. It gives me something like 2.63, 2.653. I'm going to multiply this by 1,000. And so that should be it. 2653.30.
So you multiply that by 1,000.
Okay.
That's not a lot of money.
You were like.
So if you were doing $1,000 a year, would you do the 20,000?
If you're depositing that each year as like a payment?
Yeah.
then you would have to use one of the formulas that we're using today to do that. That would be the thing that you'd have to do.
Right, but my question was not how do you. So do you just change the months to years? You just do like that. Your Y up top is going to be just if it's 10 years, it's just 10, correct?
Yeah, and so we're just doing the number of years. If we're just compounding it once per year, the total number of compounds is what this thing represents up here.
Okay.
And so we're just doing it once per year. It's just the number of years. Are there any other questions about what is that, 4B? Yeah, I mean, I know these aren't like the prettiest formulas, and they're probably like the first time you're seeing them, so I know they could probably be like a little intimidating. But on the positive side, we're not going to make you like memorize these things. But you do kind of have to know where to plug things into this. So the last time we learned these two formulas, we went over these two. This time we have two new ones. And then we have two on the returns, but that's kind of simpler. Okay, so we have this. And so before we even jump into the problems, I want to kind of get like an overall sort of like what is the difference between like what we were doing last time and like what is the difference between these two new formulas that we introduced. Well, we have A, we have APR, we have N, we have Y. We have a lot of those same variables, but one you might notice is like this has P and this has PMT. And so P here stood for principal, PMT over here is standing for payment. And so like the main thing that's different is that one of these has principal and one of them has payment. Like what does that mean though?
So in what we're doing now, you're continuously adding to that account, whereas the other is just building off of the interest of the principal.
Exactly. Like you're throwing money down here and you're not touching it at all. You're just leaving it set. You're not doing anything with that account. You're ignoring that account. This, you're actually making payments. You're making payments each month towards it. Questions about that? I'm hoping that has some resolve there. And then the other thing, they threw in these two little formulas at the end. So I got my formulas here. I have paper. Paper. Few book problems. Okay. And so I know there's only like 5 problems in here, but I want to go through them step by step. I want to make sure you have some sort of calculator or some sort of way to calculate this that will work for you. Where's the focus? That'll fix it a little bit. Okay. 15, it says assume monthly deposits and monthly compounding for the following savings plan. So it wants us to find the savings plan balance after 12 months with an APR of 3% and monthly payments of 75. So we're looking at that. Maybe fold this a little bit.
How much were the payments?
Payments were 75. And so basically, sort of keyword here, if you don't know what formula to use, they're telling you that you're making payments, right? They're not saying we're setting money in and we're waiting. They're saying we're making payments, monthly payments. So you see that word payment, I'm hoping automatically you kind of reject those first two formulas we had. You're looking at like these two. And then the second thing you have to ask yourself, are we looking for the accumulated amount or are we looking for the payment amount? Well, they want to know the balance. The balance would be the accumulated amount. So I want you to write out this formula. I want you to plug things in, start plugging things in. So they say the first thing is the payment. So they say a monthly payment of 75, 1 plus APR. They're giving us an APR of 3% right there in the problem. So N is the number of times it gets compounded per month. Or here, I guess they're talking about the number of payments per year. Sorry, I said that wrong. This N is the number of times it gets compounded per year. We are in months, so N should be 12. And then the other thing is Y, the number of years. And so they're giving us 12 months. So that might be a little tricky because we have to convert 12 months to 1 year. And so first thing, yeah.
So for that, for the NY, so would that be 12 because it's compounded 12 times for 1 year?
Yeah. So if we're looking at it, it should look. I'll give it with the numbers plugged in, so you can look at the two of them, kind of compare them side by side. Our payment was 75. We do 1 plus our APR is 0.03. We divide that by 12. My N is 12. My Y is just 1 year. And so probably the next thing I'm going to do is this is 12 times 1. I'm just going to say 12 up here, right? And so I think that's what you're asking. So that's exactly where I'm going with that. So minus 1. And I'm hoping you notice this looks like APR over N. That looks like APR over N. So some things you should see like this thing repeating in your formula. Now, I think like one of the most common things people do is they will do order of operations wrong on these things. I think that's one of the most common things they do wrong is either order of operations or they will just like start rounding just like horribly, like to not an accurate place. And then of course the next question you're going to ask is, well, how many digits do I need? And that kind of depends. It's like, how close do you want to be? Okay, so let me call on some people. Andrea, Brittany, are y'all around?
Yes.
Okay.
Yes.
Okay, so I want to do some of this stuff. So if we do 0.03 divided by 12, and we add 1 to it.
1.0025.
1.0025. Okay, and if we don't add 1 to it, it should be like what? 0.0025?
Yeah.
All right, good. Got you. And then Brittany, if we're looking at this, if we do, what did I do? How much work did I do? Let me look. If we do 1.0025 to the 12th.
It's to the 12th power
Yeah.
or to 1 year? It's to 12 months?
So it is 12 months, and 12 months is 1 year. So we did N times Y was a formula, right? So N times Y was a formula. So my N was 12, but my Y was 1.
Mm-hmm.
And so the NY is actually representing the total like compoundings that happen, or the total payments, I guess, that we're talking about now. And so if we're thinking about total payments, well, if we're doing it 12 times per year for 1 year, we're doing it a total of 12 times 1, or 12, right? And so 12 times 1 should simplify just to 12.
Right. So it will be 1.03.
1.03, yeah, I rounded it a little further.
1.030416. Yep, that's what I got.
That's what I'm getting. 1.030416.
Is it better to go, what, 6 places out?
Yeah, this is, I went to like the first, I guess, like 5 significant figures after that 0.
Okay.
It's just the more you round it now, the further it's going to be off later, sort of thing. So you can try rounding it to however many places. You can try to see how close you get. To be honest, I don't think I've ever like counted off points for people rounding unless they were just doing it really horrible. It would have to be really pretty horrendous and like a couple thousand off in the end or something. But for the most part, as long as people are showing their work, I try not to count off for rounding personally. I care more that you're doing the sort of process correctly. And so if we subtract 1 from this number, I believe we have what, like 0.030416. And if we divide that, I believe we should be getting this number 12.1664. And then the last thing we have to do is we have to multiply that, and I'm getting something around 91248. So I want to look at this, probably if I can zoom out a little bit.
So do we have to do all that, or can we just do the from 75 from what the second deal?
Here's my sort of response to that.
I did just.
My response was going to be like, how much credit do you want if you get something wrong? Because if you show me all this work, I can see if you get something wrong. I can see where it gets wrong. But if you're just going to show me something like this and then you give me a wrong solution, it's kind of hard to figure out where you went wrong there. I have to try to kind of back solve it and see if I can figure out how you went wrong. And there's a million and one ways that you can go wrong. And so if the more work you show, the more it kind of covers you in case you get stuff wrong.
Okay.
I don't know what Mr. Martinez, if you have any input on like how much work.
Restate the question. I was
Like,
chatting with somebody.
How much of this work would you expect them to show?
So I basically.
For me, like when I grade, I'm pretty lame about grading. What I do is I want to see the setup so that like that's actually there. There are calculators that will allow you to type all this in at once. Like the calculator that I use in 84 will allow me to do it. And if you have it set up and then the answer is just following that, then I probably would just give credit. I don't think I'd worry too much about breaking it down. I always like to think that there's certain pieces of math that we end up just kind of doing. Like if you're really actively doing the problem, there's usually like little pieces of work that people end up showing as they go along, and those end up telling me that you really are doing the problem. But I think the design of this really is just get the information into the formula and then use technology to do it. I think that's ACC's plan.
Yeah, I mean, with that said, like not every calculator is going to be able to do this. Straight up, just like typing it in.
Which is good that you're showing it that way, because I know I did it. Actually, I don't know if I did, but I think in the video I would have talked about like if you don't have a graphing calculator, you should start with whichever piece first, get that value figured out, and then write it down to. I think somebody asked you that earlier. like round it off to probably about 4 decimals, because they might end up being really important in the final calculation. So like as you do things, just keep a lot of decimals, just do one step at a time.
So, order of operations. So if you want to go back through this, parentheses come first. So there, I believe there's 3 sets of parentheses that I crunched the numbers on first. Next thing was exponents. And then now we have another set of parentheses in the numerator. So you subtract 1 from this number, then you divide it. And then the last thing was that multiplication.
I think it's going to be the second formula. That's the tricky one to do as parts, because they have that fraction like upside down, reciprocal. and you really have to work out. So if you're going to do it in steps, we'll see this when the next formula shows up. You're going to have to do that denominator like on its own and like hang on to that number. This one that we're looking at right now, you can literally just, once you've got that first decimal in the number, in the top, sorry, the first one with the decimal, you can then just subtract 1, press enter, divide by the 0.0025, press enter, multiply by 75, press enter. Like that one seems to just flow through. It's going to be the next one. You have to be careful that you actually write down the pieces, because then you're going to have to divide and like kind of switch the order.
Who's on the galaxy? Yeah, no response.
Is that a Star Wars question?
No, there's someone on a Galaxy Note 10 Plus is what I see.
I think that's Veronica. I think she logs in twice.
Okay.
No, I'm here.
Okay.
Can you hear
It's
me?
a spy, man.
Yeah,
It's upper management.
I'm here.
Management.
We get
They're trying to make sure that I'm actually doing the work here.
I think it drops them. What was next?
Did-
21, I believe.
Huh?
15, so we did 15.
15.
And now we're doing 21. Has a few more questions, I think. Okay, so what does 21 say? You put $300 per month in an investment plan that pays an APR of 3.5%. How much money will we have after 18 years? And compare this amount to the total deposits made over a time period.
What was the APR?
APR is 3.5%. The payment amount was $300 per month. And how much money will you have after 18 years? So reading that, I'm hoping you're looking at that problem. Hoping you're looking at this thing. Those two things. Who's around? Ian, Jason, and Lena. I think we three can take on this next problem. Okay.
All at the same time?
Well, I'll call y'all one at a time. I guess you're going to be first. So if you're looking at this problem, like you have Formula 1, Formula 2 here, right?
Yeah.
Which formula would you want?
I used Formula One.
Formula One. That's it. The first one. And so you plug things in. You plug the numbers in. And so I'm hoping your numbers look something like whoops, that.
They do.
So we have a payment of 300. We have 1 plus my APR is 3.5%. You want to convert that to a decimal. Whew. We're dividing by n. My n here is monthly, that 12. We're doing 12 by 18 years. This should look similar to that. We have this number. So the first thing that you can do is parentheses. So if you do 0.035 divided by 12, what number does that give you?
I got 1.0029.
Yeah. So it should be 0.00291, like 6 repeating, something like that. And so I rounded it to about 4 figures. If we do 12 by 18, that gives me 216. So I did the things in the parentheses first. The next thing I can do is this exponent. So I want to take 1.002917. I want to raise it to the 216. And so, I don't know, Ian, you would give me that number?
Sorry, which number?
The 1.0299 raised to the 216.
Oh. I didn't do that.
Jason, you got that number?
1.86916.
That's it.
Or do you want me to, do you round up? Because that next number is an 8. You go 1.86917.
I got 1.87602. And I probably didn't do any rounding, maybe.
So I got 1.869168112.
It's probably going to be pretty close in the end. It sounds like a rounding issue.
Oh, because I only did 1.002917. I didn't do the 17.
Yeah. Yeah. I mean, I to be honest, like even I was off from like what the book said when I did my calculations. Just a little bit, and it's just like a rounding issue. Okay, so we do that. We subtract 1 and divide. I believe we get 300, something like that. And then I multiplied by 300. I got this amount. And I think I was like something like $3 off from like what the book was saying or something.
I just think for everybody to hear here, if your rounding is a little bit different, like what Jason did, you just had a couple less numbers. The difference that your answer will be from the answer that we have when we're grading is going to be very, very small. Like, what is that, 90,000 that we got there?
Yeah.
$94. Like the rounding, if you're still going out to like 4 decimal places on things, you shouldn't be off by like even $10. I think it's going to be close enough that like if we see those numbers, the 90,000, maybe it says 84, 90,084, but I go back up and I look at the formula that you set up, it's all going to be all right. Like I'm going to know that, okay, you just rounded in a different spot than I did. And that's fair. It's not that big of a difference. Now, if you get an answer that is like 100,000, that means something totally different happened that would need to be addressed, like in that part. But rounding is only going to be like 10, 20 bucks most.
Yeah, and I was about to say, like, I'm about $3 off here. And maybe if you're buying like candy bars at a grocery store, that might be a big deal. But we're talking about like 18 years of depositing $300 a month. You're talking about out of like $90,000. You're talking about $3. Like you're not gonna care about that.
Okay, so I got 89,388 point
Hmm.
zero something, and I didn't go as far out on I only went out 4 numbers.
All right, and it was that much different?
I got 89,000.
Hmm.
$89,388.
All right, then. All right, so I'm glad that you mentioned it. All right, because it tells me that that my estimation of how far something would be off is actually wrong. Geez, man. Say it again one more time. What was the number? 89,000?
Hang on just a second. Let me run it through again. Yeah, so I got 89,389 .10.
So what is that, about 500 difference? I think it's maybe it's more like 600 or 700 like difference. It seems more dramatic because it ends up in the 89,000s. The other
But I only
so I
did
don't want people to get worried about grading.
but I
don't
only
get
did
worried about grading.
.0029.
Yeah. Okay. So the main thing I was trying to get at with is, so I was wrong on the numbers, but like on my estimate of what it would have been, but don't worry too much about like the grading part. If everybody goes out to at least 4 decimals, it's going to put you close enough to the answer. The other thing is, like, when I'm grading these, it's not me just grading one paper and trying to like figure out what that answer is and why it might be where the number is versus what I got, but I have 20 tests that I'm grading. Okay, so I'm going to end up seeing like a variance of different answers. And I think when I start looking at all those, I realize, all right, like rounding by like just a little bit difference is maybe more dramatic than I thought it would have. The answer would still look like it would be reasonable to me though. Like that wouldn't be enough to like doubt. I'm saying like if you end up like 10% difference from what the answer is, that's a significant thing. So like 10% would be 9,000. Like if you're off by 9,000, there's something else going on. All right, 700. Okay, a little more than I expected, but I guess that's what happens.
What's that? 297. Okay. Okay, and then there's like one little question more that I'm gonna ask Lena. Because she's working on other stuff. Okay, and so the last thing they talk about total deposits. I actually got it. And if we want to know total deposits, I'm not sure if they really gave us a formula for it, but I think if you just think about how much money this person is depositing, they're depositing $300 each month for 18 years. And so if you want to figure out how much money you've deposited, if you've deposited $300 each month for 18 years, how would we set that up?
Multiply the months by how many years and then multiply that by your payments.
Yeah, I was asking Lena, but thanks.
Oh, I'm sorry.
yeah, I was waiting for the chat response. No, you're good.
Never mind.
I was trying to get everyone to be active. I'm not going to complain about being ambitious. Yeah, okay. So Lena, if you do the total deposits, what number are you getting for the total deposits? Maybe I should type to her. And so if you do what, 300 by 12 by 18, is that what we're saying? Oh, she gave me the total for that one. Okay. I think you're still giving me the solution for this thing. Yeah, okay. Okay, so total deposits should be a deposit of 300 by 12 by 18. That should give you the 64,800. And so what does that sort of mean? That's it. Okay. And so what does that mean? Like, this is the amount that we have in the account. This is the amount that we've paid. So like, what is that other money called?
Interest.
Yeah, it's your interest. Okay. Questions? Okay. Back to 21. 27 is a little bit weird. Who have I not called on? Dina and Misty.
I don't understand any of it. I'm gonna go to tutoring online.
Okay.
I need it more broken down. I need like step by step.
Okay.
Okay.
And who else? Darcy.
Can
are
you read
around?
it to me? Can you read it to me? Because I can't see it.
Yeah, I was about to get into reading it. I was just making sure y'all are around and like didn't catch you off guard. Okay. So Dina and Misty and Narcy, I'm gonna call on y'all next. 20, I believe 27 is what we're on next, right? So 27 is a bit of an odd one. Suppose you are 30 years old and you would like to retire at age 60, having an that was blurry. Having accumulated a retirement fund from which you can draw an income of $100,000 per year forever. How much would you need to deposit each month to do this? Assume a constant APR of 6%. And so they talk about this in the book. They have like an example problem where they kind of do an example like this. But I guess my question, and I guess anybody that like wants to chime in can, because it's kind of weird. Like, how would you do this? How would you withdraw like 100,000 per year and do it for like kind of the rest of your life? Do it forever. Like, what is the approach there? Where's that 100,000 coming from?
That would be the interest, right?
Okay, so yeah, you're earning 100,000 just in your interest is what this is saying. That's exactly what it's saying. So we want to figure out, like, basically the approach to this is you've saved a butt ton of money and you just have 100,000 interest coming off of that ton of money. You're like Scrooge McDuck, you know, you got your vault of coins or whatever the heck you got. And you're just taking 100,000 just off the interest in that stack of money. And so they want to know, like, how much would you have to deposit each month to do that? They're wanting to know what payment are you going to have to make to get that butt ton of money. Okay, so in my notes, what did I say? 100,000 is from the interest. You're going to get an annual interest of 100,000, leaving your principal untouched. And so they're using this fact that we have 6% interest is what they're giving. And so if we have 6% interest, I guess my first question is, how much money do we need so that 100,000 is that interest? So how much money are we trying to save up to? And I guess Dina, are you around?
I'm here.
All right.
Button. So it's like a problem that we did on the handout where you're trying to find the principal,
Mm-hmm.
right?
Yep.
So it's the problem where it was the 1.5 million and you were trying to find the principal, so then it was, all right, I'm gonna try to figure out and then I'll get back to you.
All right. Should be like a quick calculation, right? Are you trying to do a complicated formula?
Oh, you're still waiting on me?
Yeah. You
So
said
I
you're gonna give me a
did
number.
1.005 and then, well, I got 3228 and then you times that by 100,000, or is that wrong? No, you divide it by 100,000.
So the 100,000 should be the interest, right?
Yeah.
Okay.
So, sorry. So I did 1.005 chat with exponent of 30 and then minus 1 and then divided it by 0.005 and then I got 32.28.
I'm trying to hear over the
Wait,
dog
I'll
barks.
I got big dogs. You know what I mean?
Yeah, I got dogs yapping too. It's like, I think it started a chain reaction.
Mhm.
Yeah. Okay. So I think you're telling me a lot of numbers, and it should be just like a little simpler. Like what we're doing is we have some sort of base amount, and we're taking 6% off of that amount, and that's going to be the 100,000.
Okay. So what do I do next?
And so you want to figure out this amount, and so if to figure out the 100,000, we multiply this amount by 6%.
And that's it?
Well, if this was multiplication and we need to solve this, we have to do it opposite. So we have to divide this by this.
Okay. I was like going to full detail.
So if you do 100,000 divided by what, 0.06?
It's 1,600. No, it's, what the hell did I do? 100,000 divided by I don't know what I'm doing wrong because I got more than 100,000.
It should be.
Oh,
That's
one.
absolutely right.
Okay. So
You
I
gotta
got
have
one,
more than
6,
100,000 because 100,000 is your interest, and so I think the number. Yeah, you're getting at it. I think right. Say it.
Yes. 166,666.67.
Yeah, I think you said the right number. Just is a little weird. It's 1,000,000
Oh.
666,000. Yeah,
There's a lot of
666.67.
sixes
Yeah,
in
that's
there.
it. That's it.
Okay.
But you have a little bit. You have over like 1.5 million, right? 1.2 million.
Okay.
And so what you're doing is you're just taking the interest off of there. And so our goal in the end is to have saved like over $1 million basically. And so if
Oh,
you
it's
save over $1
1.6
million
million.
and you have an account that has 6% interest rate, you're basically earning just 100,000 for your interest, right? But you have to have more money than the amount of interest that you're making, right?
I was doing it backwards. Okay. Now I see what you're saying. How to do it.
And so if we take 0.06 and we multiply it by that 1.2 million or whatever the heck this number is, we should be getting back the 100,000, right? Is the way to solve it kind of backwards. And so this
But
is
then
amount.
how do you know that that's what if for 30 years?
So we're not even talking about the 30 years yet. We're talking about what amount we need to save. We're not accounting for the 30 years until we determine the payment.
Okay.
We're just determining what amount we need to save by the end of the 30 years. And so it's like, what is our end goal? Our end goal is to have this amount so that we can withdraw this amount from the interest. And then you withdraw this from the interest, you're leaving this thing untouched. It's staying there. You're just skimming off the top with interest, basically.
So is the essentially 1.7 million the annual payment that you plug into the formula?
That is the end goal. That is not your payment.
Oh, gotcha.
So we're looking at this. We want to know what our payment is. We have an end goal. And so who's next? Dina, you would I not? Narcy, are you around?
Yes, I'm here.
Okay. So then the next question is going to be, if I want to know what payment I'm making, am I doing the first formula or the second formula?
You are going to be doing the I think it's the first formula. Second.
Okay, that was a 50-50 shot, and I think you went for both of them. Okay, so like which one, if you want to find out payment, one of these is solved for payment, right? Is this guy. And so if we want to know payment, it's easier to use this one. If we don't want to know the accumulated amount, it's easier to know this one. We know the accumulated amount. So we want to use this thing, this second formula. We want to know the payment. So we know an amount. We know the APR is what, 6%? N is the number of times you're getting compounded or the number of payments you're making per year. So we're doing things monthly. N should be what number? So what number is N if we're doing things monthly? Narcy, are you there?
Yes, I'm here.
Okay. I was I was asking you, making sure.
And would be the
So if they give us monthly, what number do we put in for N? If we're doing it n times per year, how many months are there in a year?
Well,
Yeah, so n should be 12. Okay, so I'm filling in this second formula. Put them side by side. I want to know the payment. My amount is that million and 2/3, whatever the heck that is, that 1.7 million. My APR over N should look like the 6% divided by 12. My N here is still 12. I guess I skipped over the Y, but the Y is he's going from 30 years of age to 60 years of age. And so they make you do a little bit of calculating in there. If he's going from 30 to 60, the number of years he's going to be saving is 30 years. And so within 30 years, he wants to reach the 1.7 million. And so I hope it looks something like this. Okay. And so the first thing we can do is parentheses. So if we do 0.06 divided by 12, I think that's going to give us an even like 0.005. And so we got 0.005 on top. We have 1 plus the 0.005. We have 12 times 30 will give me 360. So I can do the things inside those 3 parentheses first. After I do things inside those parentheses, the next thing I'm going to do is exponents. So it should look very similar to the way you sort of solved this. It should look similar, except this fraction is flipped. And so if we want to do 1.005 to the 360, that gives me something like 6.02258. Have to subtract 1 from that, it becomes 5.02258. I divide one number by the other. I think I got something like 0.009955 when I crunch those 3 numbers. And so this says he has to make payments of what, 1659, 17. I think the book said 18. So I don't want to sound too much like Regis Philbin, but Who Wants to Be a Millionaire? How do you become a millionaire? Well, you have to have about $1,600 extra dollars each month to put aside. That's all you need is $1,600. Okay. Any questions over this? Are we getting these numbers down, hopefully, and figuring out how whatever said calculator works? I'm hoping. Are we understanding why I'm using, like, what formulas I'm using, how things get kind of input to the formula, where we're putting things in? Trying to think of what to warn you about here. Okay. So, So maybe like a quick recap of this problem. This guy wanted to like basically pull off 100K from his like some kind of retirement fund. That's like plenty to live off of. More than enough than more than I've ever lived off of per year. So that is a pretty wealthy sort of income per year. How do you do that? By having even more money in your account. So how did he do that? He had about $1.7 million in his account. So if you become if you get $1.7 million in your account and you can get account for 6% interest, which probably doesn't exist, you can live off 100K a year. You can have a 6-figure income. How do you do that? Well, we need to know what sort of payments we're making for 30 years. We're making monthly payments. So each month, this guy is paying, and I'm just dropping papers off this chair. Okay, $1,659.18. I didn't do it, but if we do 16, how much total is he making? If he's paying $1,659.17, and he's doing that for 30 years, and he's making that monthly, how much money total is he going to pay in? And so if he's doing it monthly for 30 years, I believe we're doing times 30 times 12.
1910.04 cents.
For 30 years for...
Oh, okay. So 59,000.
Yeah, he's not paying
597,304. Or 301.
Yeah, he's paying that much to get what? 1.7 million? Am I doing that right? I am putting his... Okay. That's it. So where's that other money coming off of?
Interest.
Interest. And he's doing it for a really long time for a really high interest rate, right? Probably not going to find that high interest rate on an account.
Can the bank go up to 6% really?
I don't think there's any account that's high. I think they were pretty low. I think they're a couple percent points, maybe. Not 6.
1.8%.
Yeah, I think they're closer to like 1% or something like that, not 6%. And usually it's fractions of a percent that they're like off. You know, it's like around 1% and it's fractions of a percentage. It's like 1.08 or something.
I had some kids in my Algebra 2 classes that had to make up some work from before the pandemic situation, and I gave them problems that were like this because we were doing exponential functions at the time. So I had them look up a job that they wanted to get, figure out what the starting salary is, take a month of that, and I forget what percent I asked them to do, maybe like 5% of what they're going to make, something like that, and put it into a bank account, calculate how much they'll have at the end. Then at the end, I had them do the difference. But see, I was thinking about these types of questions that have like 6% interest and like how there's this dramatic change in them. And the kids were, after, how many years did I have them do it? I think it was like after 40 years of doing it, they only made like $7,000 in interest. That's all it really was. So these are highly exaggerated problems with their 6% and 7s and 5s.
Yeah, all you need is $1,666 a month extra. Grab these papers. Tangent. Okay. Where did I put problems? That's 27. Next one should be what, 29, and we have that last one. Why, what? I did have one here. No, I gotta have it on the computer. Okay, sorry. Try to yoink things out of the way real quick and shove them under something, and then you forget where you shoved them. 29 is the next one. And for this one, I don't know. I know Mr. Martinez said it felt like they just kind of tacked these formulas onto the section, and I don't completely disagree with that assessment. But those are the sort of things. We've talked about total return before. I don't believe we called it total return. It was, what, relative difference or something like that? And so this is a sort of like relative difference or the relative increase. New minus old divided by old, and then we convert it to percentage. The annual return is a little bit weird. It's new divided by old, 1 to the exponent of 1 over the number of years. And then we have to subtract 1 from that. And so who is here? Patrick and Richard look like good people. So if we want to look at 29, they want to know both the total return and the annual return. So Patrick, if you want to work on total, Richard, if you want to work on annual, and then we can talk about it. So 5 years after buying 100 shares of XYZ stock for $60 per share, you sell them for $9,400.
Could you throw that formula up there again? Because I quite frankly don't know how to do this one.
Yeah, let me do it.
Can you shift the paper? Oh, I can see that. I can see the numbers. Never mind.
Okay.
So I'm sorry, what the stock sold for at the end of the 5 years, that's the total return, correct?
So this one you do have to do a little bit of figuring to figure out what the principal is. Are you talking about, so the total return is the accumulated minus the principal.
Well, I'm just saying because you have to work it, so you sell the entirety of it for $9,400. So then you subtract that from your initial investment, correct?
Yep, that's it. That's on top. Yep. And then you have to divide that by the initial investment.
Okay, so the principal is going to be $60 per share.
So you're doing it $60 per share, and you bought 100 shares.
Okay, so it's 6,000.
Yeah, and so that's a little tricky. So I guess I'm going to throw you up there. Total returns, and so the original, I had to do a little bit of math. 100 times 60 will give you the 6,000. The final price is going to be that 94. And so maybe one thing you notice about the two formulas is like when we're talking about total return, we don't really care how many years it's been, right? All we care about is like how much we started with, how much we ended with. When we talk about annual return, that's when we're going to have to talk about how many years we had the investment. No. And so I think we got A, we got P. So I think we should be able to pretty much plug everything in for the total return.
Okay, which one was A? That's where I'm getting hung up at.
The total return?
What isn't it A? Okay, so there's A. P is 6,000. A is what?
A is the accumulated amount, which is like the final amount. What is the thing you sold it for?
Okay. That'd be the 9,400.
Yep, that's it.
Okay, let me plug the numbers in. Is it 0.056? Oh,
Yep, that's it. And then you have to multiply it by 100.
so it's 56%.
Yeah, I got 56.67 is what I got.
Yeah.
Does that make sense? Does that answer make sense?
It makes sense now. Yeah, I was just struggling through it.
This is kind of what I'm saying here. We're going from like 6,000 to 9,000, and we're doing a return of 50. That's about 50%. So if we take half of 6,000, that gives me 3,000.
Mm-hmm.
So it's an increase of about 50% of this, right? So that's another way you can kind of think about it.
Okay.
We're increasing that 6,000 by about 3,000 to get to this 94, right? Yeah. And so that's kind of what that's giving you with that total return is like how much am I increasing basically. So if it's positive, it's increasing. It could be negative. So if we started with the 94 and it went to 6,000, if it went down, this number would be negative, right? So you gotta pay attention to like what you start with, what you end with, because it's always new minus old over old, right? Was the sort of general phrasing of the formula we had. Okay. And then the weird formula.
Was that one mine?
Yeah, that one's yours.
Yeah, that'd be about 9.4% annually.
Yeah, that's it. And so I'm hoping this is a setup. This is my do it up top maybe. My annual return formula. Looks something like that. My accumulated amount is the 9,400. My principal is the 6,000. I'm doing this to the 1 over y minus 1. Now, if you're doing exponents, you want to be careful with this thing. You want to make sure this gets its own little set of exponents if you're doing it in your calculator. If not, it's going to take whatever the heck this is to the first power, and then it's going to divide the whole thing by 5. It's not going to do it in the exponent. It can do weird things. So know how your calculator works. Make sure like your numbers are aligning with what we're saying. That's why we're doing this.
I think with a question like that, if we were going to test over it, we would probably make sure that the fraction divides into a nice looking decimal.
Yeah,
There you
yeah.
go.
That's
So
what I
you get
did.
that.
I went to 0.2.
Right.
Yeah.
Yeah. So if we do something like 5 years, it divides to 0.2, which is, easy enough to work with if you can't type the fraction. But if we gave you something like 7 years and you had to divide 1 by 7, well, that number would be horrible. So like once the test is made, we've got there's both of us that can look at it and try and think from your perspective what type of technology you might be using for it. And it's easy enough for us to change it from, some bad number like 7 years to a good number like 5 years, just to make sure that you can do that. You don't need the fancy calculators.
Give him a Rip Van Winkle problem where he's in there for like a couple thousand years.
Yeah.
I used to throw one of those at the students just for fun. Like how much?
Really?
How much can you save up if you just like throw the money in there and just like wait 1,000 years or something? It's the old Rip Van Winkle or the Futurama problem, I guess. Probably had that same issue. Okay, so this, let's go through this annual return and some of these numbers. So 1/5, you can like, that is exactly 0.2. It is 2/10 is 1/5. Something that like a lot of students do, they'll do all those numbers and then they'll forget to subtract 1. I've seen it quite often. You have to subtract 1 and then you have to convert this. I know like it's really weird because in the book they tell you, if you look at this formula, this one literally tells you convert it to decimal. This one doesn't, but sorry, I said it wrong. This one tells you convert it to percentage from decimal. This one doesn't tell you to do it, but they kind of still expect you to do it. So one explicitly tells you, the other one doesn't, right? But they both kind of expect you to do this. And like Richard said, 9.4%, that's it.
Really quickly, could you put both the total and annual things up there so I can write them down real quick? The formulas, I mean.
Oh, the formulas. Yeah.
While Richard is copying those things, I was trying to jot down some notes. Might mention stuff at the end of the lesson here, and I'll go ahead and hit on the first because that's what Richard is kind of doing. as we go through this unit, and this is only the second of 4 sets of notes, you have a lot of formulas. You've got the compound interest, you've got continuing interest. This worksheet's going to have a total of 4 of them itself. It's got the one that figures out your monthly payment, the one that figures out your total amount based on the monthly payment, and then we got these 2. All right, what I highly suggest, let me back up for a second. We're going to give you the formulas for the test. We'll type them up in some format. It'll be provided for you that they'll be there. But I think what would be a really good idea for you is as you're going through these 4 sets of notes is to, actually it's more like the first 3, the last one's like totally different. But as you go through these, start to make your own like formula chart. And you should have 3 things on it. You should, for each of these, you should have a formula, like for each formula, you should write down the formula. You should then write a sentence about what it's used for. That's a really important thing because it helps organize your brain with it. And it gives it almost like more than just a title, but an understanding what you'd apply for it. And then third, do an example problem with it. And just keep a list of all of these. Okay, have the formula, have a sentence of what it's used for, and have an example. That way, when you get to the review, when we get to that point, the review should go a little bit smoother because you can read the questions that are on the review and you can match it up to either an example or a sentence that you wrote. And that tells you what formula then to pull. Okay, I think like, now I'm speaking from my perspective because I've recorded all the videos now. Like I did that this weekend, and by the time I got to that 4th one, like all these different equations are getting mixed up in my head and trying to remember which ones had -1s, which ones had other things. And like I had to keep going back and referencing. So I'm thinking if you have a list that you're keeping and you're building, it's going to pay off a lot. Okay. One of the main things is that if you create something, this is just how your brain works. If you create something, it's going to stick with you more than if you're just researching and going back trying to find them. All right, that was that. You can get back to work if you want.
Yeah, I was gonna ask that Wednesday, or are we intending to do a review for that class day, or what were we planning to do? Because I think we should be done with.
The class should be over on Wednesday. Next Wednesday, he's talking about here, right?
Yeah, because like we have 3 more lessons left, and so like Monday should be the last lesson day, right? Or the last homework day.
Yeah. So the last lesson, which will be income tax, will be on Monday.
Mm-hmm.
The review could get posted that night. I think that would be fair. And then the video will go up basically at the same time, and then they could use Wednesday to test.
Okay.
That way the class ends the last day for the Monday, Wednesday classes.
Are you guys
I didn't know.
Sorry. Are you going to do 2 days for the last test as well? Have it open for 2 days?
I mean, maybe what we could do is, this is a tough one though. I was about to say, maybe we could do 2 days, so Wednesday and Thursday it's open. But I don't know if that's a problem with somebody checking in for office hours to get help on Wednesday. I mean, you shouldn't be able to open the test and then like come back to it the next day. So I don't have an answer to that one. Do you need 2 days for it?
No, I just need to know for work. So sometimes I work Wednesday, sometimes I work a Thursday. So
I think from what I've seen with how everybody's been testing, we've had them open on Thursdays and Fridays, but everybody seems to be doing it on Friday. There might be 1 or 2 people that do it a little bit early just because they're ready to knock it out, but most people are waiting to that second day, probably because they're using Thursday to review. So what I would expect right now would be that we finish our lesson on Monday, the review and the video gets posted. If I can get that up a little bit earlier, I will. But the review and the video will be available Tuesday for you. You can take the test on Wednesday. So just open it up on one day. So you still get that day to study. Like that day would exist. You just take the test on Wednesday. You don't get to do it on Tuesday.
So is the test going to be only Wednesday, or will it be like Wednesday, Thursday?
I think just Wednesday. So it's going to still be 2 days after, like you still got the 2 days after the last lesson, but you have to take the test on Wednesday. Like you couldn't do it on Tuesday. I'm hesitant to have anything like go past Wednesday, because technically Wednesday is our last day for the course. We're not going to be doing a lesson on Wednesday. It would just be you would take the test.
Okay.
But you could take it whatever time during the day. You don't necessarily have to do it in the evening.
Is that all the questions?
I'm trying to think here, like whether or not we want to open it up to suggestions. Sometimes when you do that, it just, there's way too many different suggestions and things about that. I don't know. I think it sounds fine to do it that way, because you're still going to have time to review. And if we can get the review out next Monday, it just depends on whether or not you can have the test ready. Like if you can have a test ready, then I can make a review over the weekend. I don't know what your schedule looks like.
Yeah, I mean, it's on my schedule for sure.
It doesn't usually take me that long to make the review. I just want to see the test so that I can mimic what stuff is on it. So even if you had it done like sometime Sunday.
Yeah, I'll definitely have it done by then.
Oh, wait. Yeah, so no, that would have been the normal schedule.
Yeah.
Yeah, so I don't know how soon you could get it done. But as soon as he gets it done, I'll work on the review. I don't want to put pressure on him, though, to do it because, you know, we're still teaching the classes, and he's got 2 classes right now.
Yeah, so I got to make them a test, too. Theirs is cumulative, too, so they get extra fun.
Mm-hmm.
Okay. So final problem. Okay. All right, so this is trying to get at, what are they trying to get at? Is it better to make payments each month, or is it better to make payments like once per year? And so they give you like 2 different people's names, but they're really like keeping all the sort of variables consistent between the 2. They're just making the payments either per month or per year. And so I want you to maybe think about like overall that's what they're doing here. Okay, so let's get into like the little tidbits. Consider the following pairs of savings plans. Compare the balances of each plan after 10 years. In each case, which person deposited more money into the plan? Which of the 2 investment strategies do you believe is better? Assume that the compounding and payment periods are the same for each pair. Okay. So for this one, they're not saying that Yolanda, I read this really weird at first. They're not saying Yolanda and Zach have the same compounding periods. They're saying the payment periods and the compounding periods are the same, I believe is what this last statement is trying to say. It's a really weird statement. And at first when I read it, I thought they were saying these 2 peoples had the same compounding period. That's not true. So if we read this, Yolanda deposits $200 per month in an account. Its APR is 5%. Zach is depositing $2,400 at the end of each year. The APR is going to be the same. Before we do this, if you were to take a wild guess as to which one of these is better, which one would you think would be better? Just knowing kind of what you know from like last class's lesson.
They're the same.
They are the same, but this is making payments or it's being compounded monthly. This, guys, is going to be compounded yearly.
Oh, okay, that's cool.
Yeah, and so which one? Yeah, someone already said it. Yolanda, definitely. She's doing it monthly. And so this next one was Xavier, Tina, and Romeo. Xavier, I want you to figure out what Yolanda's accumulated amount is going to be, is what we're trying to figure out.
That's the first part of it?
Yeah, so figure out what Yolanda's going to get.
Okay.
Tina, I want you to figure out what Zach is going to get.
Okay.
And then Romeo, I'll ask you some questions in a minute and ask you to compare the two. I am going to go take like 5 minutes right quick. I'll be right back. Okay. Xavier around?
Yeah, I'm not too sure if I did this right though.
What are you getting?
So you wanted me to do the total return formula, right?
It should just, we're figuring out what amount she has. So she's making payments. She's making payments of 200 per month. And you should be figuring out the accumulated amount, or the amount after this. So accumulated amount is the amount that she has after a certain amount of time, right? And so we want to figure out the accumulated amount given that her payment's 200. The APR is 5%. She's doing it monthly. And she's doing it for 10 years.
All right, give me a second. Yeah, I definitely don't think I'm doing this right.
What number are you getting?
It's giving me a crazy number.
Got it set up something like that, hopefully. So the payment is 200. The APR is 5%. The N is going to be 12 for the monthly. The N here is 12. The Y is 10. Subtract 1. This is my APR over N. What? Where are you going to write here? Like, are you getting the 0.05 over 12?
I'm not too sure how to really solve it from that point right there
Okay.
in the calculator.
Yeah, so we do 0.05 over 12. So you want to hit like these parentheses first. So we got 0.05 over 12. We're going to add 1 to that. And so that gives me like 1.044. I didn't even write out all the steps on this one. So I have 1.004167. That's this thing. This thing I can do right quick. That's going to give me 12 times 10 is going to be 120. I still have to subtract 1. And I still have to divide this by this thing without the 1. So that was 0.004167. So if you're doing this piece by piece, the next sort of piece should look something like that.
So that's the part that I should have got after that.
Yeah, and so that is just coming from taking this number and dividing it, right? If we take this number and divide it, we're going to get 0.00416 repeating, or 4167. If we add 1 to this number, we're going to get 1.004167. And so the first thing I'm sort of doing is just like looking at this number, converting it to a decimal, adding 1 to it here. The next thing I'm doing is this exponent here is 12 times 10. I'm going to do that as 120. And so that's giving me the fraction. I guess I dropped my 200 multiplying by this crazy thing.
Yeah, I guess the point where I'm getting confused at is just where to solve from next once I get it written out.
Okay. So now we've done parentheses. The next thing you want to do this exponent. So you're doing 1.04167, 1.04167, and we're going to raise that to the 120 power. So if I raise that to the 120 power, ooh, I'm off by a decimal, 1.004167. Make sure you put enough zeros in there. If I do that, I should get something like 1.647. Something like that. And so I raise this thing to an exponent. It's going to give me this solution out of my calculator. If I subtract 1 from this top number, it's going to give me 0.647. 0.075. Now I'm dividing this by 0.004167. How close I am to what I did earlier.
I'm sorry, I didn't hear that last part.
I said, let's see how close I am to what I was doing earlier. And so we subtract 1 from this, it becomes this number. I'm getting something like 155.28 for this thing on the right, this crazy thing on the right. Yeah, that's close enough. I think you should be 31.056. And so this is Yolanda. This is how much money she would have. The other question is, how much money did she deposit?
Wait, how much overall? It was still 2,400.
Yeah. 24,000.
Oh, excuse me.
Because she's doing 200 by 12 by 10, right? And so she put in 24,000. She's getting 31,000, right? And so we could probably figure it out, but she's making about how much in interest? Just like ballpark figure, I guess you can give me, right?
A little over 7,000.
$7,000.
Yeah, about 7,000. 7,056, I think, right? Okay. Questions about Yolanda? So this is Yolanda's. The next thing we had to do. Is Tina around?
Yeah, I'm here.
All right. So the next thing we had to do was we had to figure out Zach. And Zach was depositing 2,400 into an account. And so what am I hoping you did?
For that one, I will have use the same formula to find the amount, correct?
Yeah, so you're using the same formula.
Okay. So for that one, I wrote down 2,400 times the parentheses 1 plus the APR, which is 0.05 divided by 12, close parentheses, and then the upper parentheses, which is 10. Oh, I didn't see you put it down. Okay.
So this, when we're dividing this by n, right?
Yes.
And n is the number of payments or the number of times you compound per year. And so if he's making this payment once per year, the N should be what number?
I put 12, or
If he's doing, if it would be 12 if he's doing it monthly, right?
yes.
So if it said it was doing it monthly, you'd be absolutely correct with the 12. This says once per year, and so if it's like once per or annually, I guess is what it says. I just gave you probably the solution there. If it says annually, that means how many times per year?
So just 1.
Yeah, and so you can think about if this is dividing by 1, you can think of this as maybe multiplying by 1 right here. You can think about this as maybe, hey, there's a dividing by 1 here. But all in all, that 1 isn't really doing anything when we divide by 1 or we multiply by 1. And so right away, like you might have noticed in my notes, I didn't even write it there. I just like completely left it off.
Oh, okay. All right. Here, I pretty
But
much
it
did
sounds like everything else you're plugging in is correct. It's just like that N.
the input part. I didn't really.
Yeah, and it's really it's really kind of confusing because we have 2 different variables that mean time, right? We have N and we have Y, and they're both variables that represent time, but Y is the number of years and N is the number of times per year.
Correct.
Yeah, and so we got to get those things. So this represents the 10 years. This represents the number of times per year.
So what I did 1.05 to the 10th to the 10th x power, and I got 1.62 89.
Yeah, I didn't do all the middle steps in here. I'm going to double check. 0.05.
That's correct.
To the
Okay.
Yeah, that's it.
Okay, so all right, give me 1 second. Okay, and then I divided by 0.6289, divided by the APR, which is 0.05, and I got 12.578.
That's it.
Okay, and then I did a 2,400 times 12.578, and I got 301. Well, 30,187.2.
Yeah, that's it. And then if we look at his total deposit, he's depositing 24, and he's doing it for 10 years, and he's doing it once a year. And so I don't want to spend like a whole lot of time. But you might notice his total deposit is the same amount of total deposit that the other one's making, right?
Right.
And so they're both depositing their amount into 2 different accounts. And I guess I got to pick on Romeo at some point. Is Romeo around?
I'm here.
All right. So Romeo, I'm going to ask you the really difficult question. I can zoom out a little bit, maybe. Which one of those would you rather have? I can't hardly. Yeah, it's not going to fit both of them. Which one of those accounts would you rather have?
I guess Zach's.
Zach's or Yolanda's, and why?
I would say Zach's. I mean, he has a couple, like, he has a little over 100 more dollars in here, and you're only paying 1 time instead of paying 12 times like Yolanda is. Even though it's more of an amount, but even though you're paying more of an amount than she is at the end of her, like you're paying more than she is like monthly or whatever, you're still getting a little more than $100 back.
Okay, so Yolanda made 31K, right?
Yeah.
And Zach made.
Oh, I thought you made 31. That's my fault. I looked at it wrong. Yeah, I guess Yolanda then.
Yolanda. Okay, yeah, that makes a little more sense. And
$1,000
Yolanda, because
over. I looked at
Yolanda's
the numbers wrong. I thought they both said 31,000.
no. This is a little bit more. This is about like what, $1,000 more, a little bit less than that, maybe.
Yeah.
Yeah. Okay. So I think pretty much everything you just said, but now saying Yolanda because she has more amount of money. Right? Okay. So Yolanda, she's got more amount of money. They both paid the 24K. They're both paying the same amount. They're just paying it in different intervals, right? One's paying $200 a month. The other one's paying $2,400 per year. It's still the same amount. But is it better to, like, the question then, is it better to do it monthly or is it better to do it yearly? And before we even look at this problem, like, y'all could pretty much tell me if from last lesson, like, it's going to be better monthly, right?
Yeah, monthly.
Yeah, and it's a little bit better, not a whole lot. Okay. And any other questions about this? Someone was talking about per month. Okay. So that is the final problem.
Could we possibly go back to number 27?
Okay.
I believe, yeah.
Let's see. 27.
Can I go ahead and take my son to work?
Yeah.
Can we go ahead?
Beautiful and just white. So I'm trying. So number 24 on our homework is really similar. I'm trying to work through that, and the answer I'm coming up with makes absolutely no sense whatsoever. So if we could walk through 27 again, that'd be great.
Okay, so you want 100,000 just from the interest, and we know the APR is 6%. And so what they're saying is this 100,000 is 6% of some really big number. And so the first thing is we need to figure out that amount. So if 6% of some amount is going to give us 100,000, then the way we figure out the amount is by dividing by this. And so you have to divide both sides by that 0.6. So maybe I could write that in maybe some red pen or something. And so that step is called the divide by 0.06 step. We divide 100,000 by 0.06. I forgot how to drink water. Okay, sorry. And that gives that, okay, so we divide by that 0.06. The 6% gives us a 1.7 million that we need to get. So that tells us our end goal of what we need to reach. And so then we go and look back at those crazy formulas. We want to know the payment. We know the accumulated amount. So this is the formula we want to use, is the second formula. We're trying to figure out the payment. We just figured out our A was the 1.7 million. Our APR is given to us. Our N is given to us in the problem. And then Y, they give us 30 years for this guy to save. So that is all given in the problem somehow or some form. And so looking back at this, now we want to find the monthly payments for 30 years. I'm plugging it into this formula. My accumulated amount is at 1.7 million. My APR was the 6% that they gave me in the problem. My N was 12 months per year. I'm making payments monthly. 1 plus APR over N. What else do I need? Y was for 30 years. If we divide 0.06 by 12, I believe we get 0.005. If we add 1 to that, we get 1.005. 12 by 30 will give me the 360. And so that first step, there's like sort of like 3 sets of parentheses I can crunch numbers in. So I crunch those numbers. I hear myself echo back. I do this 1.005 to the 360 power. That gives me something like 6.02258. And I know I didn't do the subtraction step, but if I do 0.005 over 5.02258, so I have to do the subtraction before I do the division. I know I was a little lazy with that. If I do that division, I should get this number like 0.0009955. I multiply that by the million, and it gives me 1,659. And so that tells me the payment I need to reach 1.7 million.
One thing about this question versus what's on the worksheet for 24, this question has that beginning part where you need to figure out what the balance you need is in 30 years. Question 24 gives you that number at the beginning. Okay, so what Severs is got on his screen right now, that's where the calculations start. It begins at that spot. So you don't actually do that beginning piece for 24.
I just don't understand. I plugged this into both my calculator as well as a different calculator, and I keep coming up with a decimal answer, which makes absolutely no sense.
Right, you get a decimal after you multiply by a million.
Yeah, it should look really similar to this one. I think they're giving you 6% APR and they're giving you 30 years.
Yeah, so where the problem on the screen's got the 1 and all the 6s, that's going to be $1 million. It's going to be $1 million. So if you're multiplying $1 million by the other part and still getting a decimal, that means you've got this ridiculously low number. I'm not sure how to figure out where that is. If you ended up with a negative number, I know where that would come from. But I can't figure out how your value is so tiny.
Any other questions?
I think with that one, he just needs to keep running the numbers on it and figure out like small details where it is. Break everything down. What is the exponent supposed to be in 24? I think it goes for 10 years. So the exponent might be 120.
No, it says 30 years. I think it's
Oh, 30 years? All right, so it's still 360 then.
Yeah, you should be getting the same numbers as like this one, pretty much, or a lot of the same numbers.
Then maybe what you want to do is try and run the numbers that he's got in this problem to make sure that you're able to get to that 16,000, sorry, the 1600 that he's getting in this answer. Once you figure out whatever it is, some little detail in there, then you can do your problem. But you know this one and you know the answer. So just kind of play around with it. If you aren't doing it in little parts, it's probably parentheses, and I would just go and do it in small pieces.
Yeah, if I were to guess, it's probably got something to do with the exponent part, but that's just a complete wild guess. It's just like, typically it's like one of the things that people kind of go awry on in this formula.
I'm looking at it trying to figure out how's that number becoming so small that, because if he's going to multiply $1 million by it, then that means he has to have something that's got, you know, like way back there.
A lot of times people won't raise this to a power, they will multiply these two numbers. And raising something to a power and multiplying something are not the same operation.
Yeah, that could be it.
Yeah.
That'd give you a bigger denominator. Anyway, I was going to comment on 4D before everybody goes. Care if I do that? The approval. I also have to get a Star Wars reference in today. So I'm gonna hit it on 4D. All right, so 4D, what you're going to be doing next. Oh wait, before I talk about that, formula charts. Like, I'm serious, make a chart. I know that they're all printed in the text, and like as you're going through things and you're doing one activity, then the next one, and one problem, and the next one, you're going to do all right with it. But you got to be thinking big picture that like next week, yeah, it's next week, right? Next week, you're going to have to take a test, and there's going to be all these formulas that you could get mixed up on. So if you're making your own chart as you go, your brain's going to start organizing all the information. So definitely do that. All right, so 4D it's a lot like what's happening in 4C, except instead of saving money, what you're going to be doing is paying off a loan. But the part that's going to be similar is you're going to be making monthly payments. So you still got this process of making payments as you go, but what you're trying to do is like break down what you owed, right? You start with a high balance, well, assuming it's high, you know, whatever number it is, and you're trying to get that down to zero. But what you're doing in 4C is you start at zero and it's just accumulating. So there are similarities. It can get confusing in the equations if you're not really like ready for it. So one suggestion with 4D, read over 4C right before you start those notes. Like just glance at it 5 minutes just to get your mind like back in the state of what was happening in 4C, so that 4D you can naturally create comparisons. All right, Star Wars reference. In 4D, the first page is going to go really smooth. You can be like, ah, this is a piece of cake. The second page, problem 6, 7, 8, and 9. They have you do this guess and check method, and it, to me, just turns into a big disaster. All right, so 6, 7, 8, and 9. In 4D, I want you to think of that as the Jar Jar Binks of the notes. Okay, if you were just to take out problems 6, 7, 8, and 9, just take them out of the notes and do everything else, the notes will go really great and you'll enjoy them. With Jar Jar Binks in the notes, it kind of ruins the whole thing. Okay, so when you get to that part, do the problems. Do 6, 7, 8, and 9. Do them, but remember, these are just Jar Jar Binks. Don't get too hung up on them. If it doesn't make sense, you don't understand Jar Jar Binks, just go on to number 10, and the rest will go really smooth. Okay? Everybody knows Jar Jar Binks, right?
If they don't know who Jar Jar Binks is, we can't be friends.
He was not a Sith Lord. I hope that was sarcastic. All right, cool. Man. I had a friend in high school. This is back when we had VHS, though. And he took a copy of episode 1, and he made his own copy of it, and he just cut out all the scenes of Jar Jar Binks. All right, Ian's giving us something to look up, I guess, on Jar Jar Binks. Let's highlight that.
I want to say that this isn't the appropriate place for it, but it is a math class, so it probably is the appropriate place for it.
Star Wars? Is that what you're talking about?
No, I was just making a horrible joke. But yeah. I guess if we're just going to talk about Star Wars, I'm probably going to stop the recording.
I'm trying to research what Ian sent me. I'll read it a little bit later, but I pulled it up already.
Okay. I think we're pretty much done with the lesson for today.